that you get very, 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 very close to as x gets very, very, very close to c, but you never actually touch that number n. So for example, in a graph, okay, if you have some function that kind of looks like this or something like that, and this is c, okay, and over here you have some number n, okay, and this is the x-axis. So as x gets very, very, very close to this number c, do you see that I get very, very close to this number n? Good. And that's basically what a limit is. As I get very close to some number, what number does my function, in this case f of x, get very close to? Okay? And the value of the function and the value of the limit aren't always the same. Okay? So for example, I could have a function in which I have a hole in the graph. Okay? So that's not a very good hole in the graph. But I might have something that looks like this and this. And instead of this being n on my eraser, I got used to using this eraser, now it's stopped working. And because there's one on the pen that anyway, I'll show you. So you could have something that looks like this. As this function gets very, very, very close to c, as x gets very close to c, what y value do I approach? Look over here. 2. Okay? So as I get very close to c, the function approaches 2. So in this case, the limit as x goes to c of f of x, let's say limit is equal to 2. Even though f of x, f of c is not equal to 2, it's equal to this point up here, right? So if I plugged in exactly c, this is called a removable discontinuity, which we'll learn in the next section. But exactly at c, the value of the function is what? 3, right? So exactly at c, the function has a value of 3, but as I approach c, the limit is 2, okay? And in order for something to have a limit, it has to approach the same value from both sides, okay? So going this way or going this way, I have to approach the same value, okay? So for instance, if you have a function that looks something like this and something like this, where this is like 1 over here and this is 2 and this is c, and the function is like a piecewise function where you have one rule up to this point, another rule up to this point. At the limit of f of x, as x goes to c, you could say it is d and e. You know what d and e means? Does not exist, because as I approach c from this side, the limit is 2. But as I approach c from this side, I approach the y value of 1. Okay? So because I'm approaching 2 different y values from opposite sides, as I get closer and closer to c, then you can say the limit does not exist. Okay? So if you see something like that, and you're evaluating it at c, then the function does not exist. But you could have something like, what's the limit? Let's say this is, and I'm not even looking at my notes now, I should. Okay, but say this is point D. What's the limit as x goes to D? What's the limit as x goes to D? 3, right? So you can have a limit at some point, but not at other points, you see? So if there's like a break in it, and you're evaluating it at that break, then it won't have a limit at that. Okay? Let me look. So then you could do limits there are ways to evaluate limits that are pretty straightforward. So find a limit as x goes to 2 of 3x squared minus 1. Anyone want to tell me what that limit is? What value? Not the eraser doesn't work again. Okay? So, I'm going to write an equal sign. Equals, what is it? 11. All you really have to do in this case is plug that number in. Okay? So 3 times 2 squared is 4 minus 1 gives you 11. And that kind of makes sense because this is a parabola, right? So 3x squared minus 1, what does that look like? It's a steep, kind of a steep parabola that kind of looks like this. And as I get closer and closer to 2, right? As I get closer and closer to 2, I get closer and closer to the actual value at 2, which is 11. Okay? Now you can see that on your calculator by plugging in numbers, but we'll do a more interesting one with your calculator. So if it's just a quadratic function or a continuous function without any poles or asymptotes or anything like that, then it's relatively easy to evaluate the limit. If it's a polynomial function like this, all you have to do is plug in and you'll get the limit. But if you have something that's a little more complex, as in the limit, so say we have the limit as x goes to 1 of x squared minus 3x plus 2 over x minus 1. Okay? What happens if I just try to plug 1 in here? I get a 0 in the denominator, so you would say, well, this doesn't have any limit, but it does have a limit because even though it's undefined exactly at 1, there's some value that it's approaching as you get to 1. Now, there's a way to see that on your calculator, and there's a way to do it algebraically. First, I'll show you how to do it on your calculator. So, my calculator is right there, and all I do is I plug in, I have to go to mode, get out of that sequential mode. I want to go to function mode, and y equals, why is it looking weird like that? What's that stuff? There we go. So, say, what was it, 3x squared minus 1 that I put in there? 3x squared minus 1. Plus, what did I say?
Plus 2.
What? Oh, sorry, I should have written my note. It was, it's x squared minus 3x plus 2, sorry. I could probably bring that back up here. Where did it go? Is it there? There it is. X squared minus 3x plus 2. So, x squared minus 3x plus 2. Okay, so I want to see what's happening with this function as I get very close to 1. So I go second table set. Is this table set? Table set right there. Okay, and I don't want to start at 200, right, because then I'm going to be past where I want to find my limit at. So what you want to do is like plug in like something like 1.9, okay? And then you'd want to go up in very small deltas, very small increments, because you want to see what's happening as I get very close to 2. So I'm going to plug in, even 0.1 is too small, so I would plug in 0.01, okay? And now if I go to my second table, okay, I can see that as I get very close to 1, it appears to be getting very close to some number, which appears to be, what does that look like? Negative 1? Negative 0.0. I think I did something wrong. divided by, in parentheses, like that doesn't look right, x minus 1. And now if I go to my second table, I can see as I get very, very close. What? Did I forget something?
Go to table set. Go 1.01.
Second table set.
You have to start at 1.01.
1 point. Why do I have to start at 1.01?
Because you're getting close to the borderline.
Oh! Because I'm stupid? That's what? Okay. So sorry. So I want to get close, so 0. So what if I start at 0 point? Yeah, 0.9 or something like that. Does that work?
Yep.
Okay. So then I'm going to go second table, and now you can see as I get very, whoa, I'm sure I'm doing something wrong here. Now I know what I'm doing wrong now. 200? Does it look like I'm getting very close to 200? No. Let's try something else. I think I have to put this top, we should stop this video right now. So we're going to go, boy, this math teacher is bad. Second, insert parentheses, and I'm going to go over here and put a parentheses over here. I think this second insert parentheses. Let's see what happens now. Second table. Oh, this is looking better. Okay? So it's good for you to see, because if I'm making these mistakes, some of you are going to make these mistakes too. Okay? So I was just trying to teach you guys the mistakes that you were going to make when you were doing this. All right? So if you look up here, you have to put this in parentheses. Otherwise, it's going to just divide 2 by that thing, right? So you have to put both the top and the bottom in parentheses. And now when I go to second table, you can see that as my number gets very close to 1 from either side, what number do I get to over here? Negative 1. Okay? So using a calculator, you can figure out that the limit of this is negative 1. And if I set my increment to 0.001, I would get even closer to negative 1. Now, algebraically, we talked first semester about how to do this. Anyone remember what that is? What should I do at the top? What can you do at the top? You can factor it out, okay? So you can go x times something. You want it to do a factor. Is that minus 1 minus 2? Okay? And usually the top and the bottom will cancel out, and you can go boom like that. And when you plug in 1 into here, now what do I get? What do I get? Negative 1. See that? So now I can take that 1 and actually plug it in, and I can figure out what the limit is. Okay? So even though this particular function is not defined at 1, okay, it has a limit of negative 1 as I get very close to it. You get that? Now you do it out there. Okay. So then I want to talk about some other things. I already talked about limits that don't exist and holes in the graph and stuff like that. Let's talk about piecewise functions. So with limits, a lot of times you will see things that look like this. Find the limit of f of x as x goes to 2 of for if f of x equals, and then they do something like this, 2x minus 1 if x is not equal to 2, and negative 2 if x of this, more or less. Let's see if I can get some arrows on it. Let's make a solid line. Put some arrows on it in my graph. Let's make it colorful. Colorful. And there it is. Okay. And so this is a function who looks like a line, 2x minus 1, for all values except for x equals 2. And so what's the slope of this line? 2, and the y-intercept is negative 1, right? So it has an actual y-intercept that goes through negative 1, and it has a slope of over 1 and up 2. So another point on that graph would be right there, right? And then if I were to draw it in using my, where's my line tool? There it is. Okay, I'll draw it in a different color. So my graph would look something like this, except right at x equals 2, I have a hole in the graph on the line, and at x equals 2, what's the value of that function? Negative 2. So at that point, I had something like this. Okay, and you say, where would I ever see a function like that? I don't know. In a math book. Okay, but there are some real life applications of it. Okay, so they want the limit of f of x as x goes to 2. So what value am I approaching as I approach 2 over here? Yeah, all I have to do is plug in 2 in here, right? 2 times, even though the function is undefined at 2, if I plug in 2 in here, I get 2 minus 1, which is 3. So I could get as close as I want to this point, okay, without actually touching it, and my y value will come out to be 3. Okay, so the limit as x goes to 2 is 3, except, I want this thing. I want to make that eraser smaller. Except that, I hate when that, okay, maybe I could just do this again. There we go, okay? Except right at 2, the value of the function is negative 2. So f of 2 is equal to negative 2. And there's actually a way to plug in piecewise functions into your calculator. You want to see that? I Googled it last night. Okay, so if you go to y equals, this is the way you do it. First you hit clear. First you go over here and you hit clear. And I was plugging in this function right here. So the way you do it, you go 2x. Let me see if I can remember. 2x minus 1 for x is not equal to 2. So if you get your parentheses and you go x, and then remember when you did the restrictions with your I don't think in this case. Okay? And we'll see if it comes out messed up or not. Okay? For x is, and then you go second test, and you have the not equal to sign right there, number 2. For x is not equal to 2, okay? And then you close that parentheses, and then you hit, because I think it recognizes that as a restriction on it once you put it in, and then you hit the plus sign, okay? And I guess that's equivalent to the and sign, okay? And then you go, this is like y equals negative 2. So you go negative 2, and then you go parentheses for x. And again, you have to get that equal sign. You can't hit enter, I don't think. You just hit the plus sign down there. Negative 2, second test for x equals 2. And then let's see if it will draw the graph of that. Hopefully it recognizes that. And if I hit graph, there, let's second format, my axes are on, go to your second table, okay? Let's go second table. Okay? Let's go second table. Okay? As I get very close to 2, oh, I want to go second table set. I want to get close to 2. Okay? So 1, am I doing this right this time, Antoine? 1.9? Okay? I want to see what happens as I get very close to 2. So second table, okay? So you can see as I get very close to 2, right? I get very close to what number? Hello? What number am I getting close to? 3, right? But look, right at 2, what number do I get out here? I get out, what do I get out 2? That should say negative 2. That should say, maybe I put it in wrong. Okay. Should I get out negative 2? 2 if x equals 2. I don't know why it's saying negative 2 there. Why it shouldn't say, it should say, oh no, it should,
No, it should say negative 2.
it should say negative 2. And I don't know why it's not. So, that's some way I entered it into my calculator wrong. I'm not sure. But it says 2 instead of negative 2. And I'm not sure why. But I'll get back to that. If x equals 2, y equals negative 2. Okay, anyway, we'll come back. So, what else do I have for you? What about, let's just look at one more piecewise function and one more rational function. So, another piecewise function is find the limit as x goes to 0, of f of x, okay? Where f of x is equal to another piecewise function. 2x if x for x is less than or equal to 0, and it's equal to 2 if x is greater than 0. So if I were going to graph this function, let's see if I can do that. Yeah. If I were going to graph this function, it says x is less than or equal to 0. You use a line y equals 2x, which is, it goes through 0, 0, right? And it has a slope of 2, so it's going to look something like, let's grab my straight line tool. It's kind of a steepish line, and it's going to go this way up until that point, and including this endpoint right here. So that would be a closed-in circle, okay? After that point, it turns into y equals 2. What does y equals 2 look like? It's a straight line going across, right? So right at x equals 0, if I go up 1, 2, I put an open circle there because it said x is greater than, not greater than or equal to. Here I put a closed circle because it says x is less than or equal to 0. And at that point, I have a line. I want to make my line not have arrows on both ends. I have a line going from that point over this way, okay? And so that's what that particular piecewise function looks like. What is the limit? So what is the limit as x goes to 0? No, it's not 0, because it's approaching 2 from this side, and it's approaching 0 from this side. So what do you say? DNE, okay, does not exist. What if I asked you what is the limit as x goes to, for example, what if I said what is the limit of this function as x goes to 5? Okay? As x goes to, say this is 5 over here. What would be the limit as x goes to 5? What is the y value? 2, right? In that case, the answer would be 2. What if I asked you the limit as x goes to negative 1 of f of x in this case? What would I get? It's on this line, right? So all I do is I plug negative 1 into that function, and I would get out what? Negative 2. You see that? So as x goes to negative 1, it's perfectly okay to find the limit right here. The only place it doesn't have a limit is where that break is. Okay? And then the last thing you're going to see is to find a limit with your calculator, which you could, I already kind of showed you that. So say you have something like this. Find the limit as x goes to 2 of x cubed. This is one of your examples out of the minus 2x squared plus 4x plus 4x minus 8 over x to the 4th minus 2x cubed plus x minus 2. And it is possible that you could plug in a 2 and get out an answer. Okay? However, I think if I plug in 2 in here, I'd get negative 8 over 0. Right? Okay? So that means that it's undefined at that point. Probably I have an asymptote there. And I would have to go through factoring this thing, which is a big pain in the neck. So you could just do that with your calculator. Okay, so you would plug that big ugly function into your calculator, not forgetting to put this whole thing in parentheses and that thing in parentheses. And then you would plug in values very close to 2, like 1.9, 1.91. You want me to do that? Yeah, let's do it. Okay, so I'm going to go over here. And you don't always find the limit as x goes to 2. You can find limit as x goes to other things too. It just happens that we pick this number. So I'm going to go x to the 3rd. X to the 3rd minus 2x squared plus 4x minus 8 divided by, in parentheses, x to the 4th minus 2x to the 3rd plus x minus 2. And then I'm going to go second table set, and I'm going to plug in numbers very close to 2. And again, I'll go up in increments of 0.0. What?
You get 0 because the top.
You get 0 for the top?
Yeah.
If I plug in 2 in here?
Yeah.
So, I get 0 over 0, right?
So you get 0.
I get 0 on, I do get 0 if I plug in? I don't get 0 on the bottom?
I don't know, but you get 0.
Oh, you get 0 on the top. And on the bottom I get 16 minus 16 plus 2 minus 2, right? So I get 0 on the bottom too, right? So that'd be 0 over 0 if I try to plug into, which is undefined. So then I'm going to go to the table, second table, and look at what value I'm getting close to. And it appears that I'm getting pretty close to 0.8 something, right? So to get even closer to that limit, I might do something like plugging in, because they might ask you to the nearest hundredth, what are you approaching? So So I could go to 0.199 here, and then I'm going to change this from 0.01 to 0.001. And then I'm like zooming in on my values, okay? So now if I go second table, okay, now I can see that as I get very, very close to 2 from either side, okay, I am getting very close to 0.88, 0.889 or somewhere around there. You see that? So about 0.89. So the limit, even though you get 0, 0, it's about 0.89, something like that, or 0.88. Okay? So that's the way you do it. Your homework class, since I don't think I have a posted assignment sheet yet, is going to be page 914. Page 914, 1 through 6.
What, you said this is not on the website?
I don't, I think I might have this on here, but just to be safe, I'm writing it out. 17, 19. Um, 29, 31, 37, and 40 and 43. And that's all you got. Okay? There you go. Look at it. Stop the recorder.